and welcome to lecture 1.4, Subtraction of Real Numbers. Now we have a rule, and if we think about it, subtraction is just the opposite of addition. So we can change every subtraction problem into an addition problem. So to subtract one real number from another, we're just going to add the opposite. So if A and B represent two real numbers, then it is always true that A minus B will equal A plus negative B. So all combinations of positive and negative 7 and 2 would be 7 minus 2, which is 7 plus negative 2. Answer is 5. Negative 7 minus 2, negative 7 plus negative 2 equals negative 9. 7 minus a negative 2 is really 7 plus, what is the opposite of negative 2? Positive 2. So that 7 plus 2 is 9. And negative 7 minus negative 2 is going to be negative 7 plus 2 as negative 5. So when you have minus a negative, you can think of it as take away the negative. I know a lot of people say for minus, take away. So take away the negative. Or do the opposite of a negative, which is positive. So 7 minus negative 2 is going to be 7 plus positive 2. So let's take a look at a couple of expressions and simplify them. So 7 plus a negative 3 minus 5. Now I'm going to rewrite this all as addition. So 7 plus negative 3 plus negative 5. Now if you remember your order of operations, we're going to take adding and subtracting. They're the same level of operation, but we're going to change this all to addition, and we're going to go from left to right. So 7 plus negative 3 is a 4. Our problem now becomes 4 plus a negative 5. 4 plus a negative 5 is negative 1. Hey, 8 minus a negative 2 minus 6. Well, a negative 2 is going to be adding the opposite of negative 2, which is positive 2. So 8 plus 2 gives us 10. 10 minus 6 gives us 4. 2 minus, in parentheses, so this is a grouping of negative 3 plus 1 minus 5. Now we do the parenthesis first, so we have to do the parenthesis first. So negative 3 plus 1 is going to be a negative 2, but we have this negative sitting out there that we have to take in consideration. So a 2 minus a negative 2 is going to be the opposite of negative 2. So 2 plus positive 2 minus 5. Well, negative 2 plus 2 is 0. 0 minus 5 is negative 5. I'm going to run through a couple of problems that might be a little bit more complex to you, and you're just going to follow your order of operation. So we have 2 times 5 minus 3 times 8 minus 4 times 9. Multiplication is in the higher realm than adding and subtracting, so we're going to do the multiplication first. So we have 2 times 5, 3 times 8, and 4 times 9. So 2 times 5 is 10, 3 times 8 is 24, and 4 times 6 is 36. So where I saw those grouping of multiplication, I'm going to replace with the result that I ended up getting. So it's now going to be 10 minus 24 minus 36. Well, that's going to be 10 plus a negative 24 plus a negative 36, giving me negative 14 plus a negative 36, so the end result is 50. Okay, let's try another one using our order of operation. We always have to follow order of operations. If I don't, and I just go from left to right, let's consider what this will be. 2 times 5 is 10, minus 3 is 7. 7 times 8 is, 56. 56 minus 4 is 52. 52 times 9 is really big. Right? That's going to be 468, right? That is certainly not a negative 50. So unless we follow the order of operation rules, we're not guaranteed to get the correct answer. But if we do follow the order of operation rules, we will get the number that we're expecting. Thus try 3 times 2 cubed minus 2 times 4 cubed, 4 squared. Parentheses, exponents. Exponents come first before multiplication or subtraction. So right now I have a multiplication, right there and right there. I have subtraction, right there. And I have exponents as well. So I have 3 types of operations. I need to do them in the correct order. So 2 cubed is 2 times 2 times 2, which is 8. 4 squared is 4 times 4, which is 16. So where I saw the 2 cubed and the 4 squared, I'm going to replace that with 8 and 16 respectively. So now my new problem is 3 times 8 minus 2 times 16. Now remember, multiplication comes next. So I'm going to do the problem of 3 times 8, which is 24, and 2 times 16, which is 32. And wherever I saw my 3 times 8, I'm going to replace with the 24. And the 2 times 16, I'm going to replace with the 32. Now I have 24 minus 32. But I can rewrite this. You might not need to, but if you do, you can rewrite this as an addition problem. So that is 24 plus a negative 32. Since they're opposite signs, I take the difference and give the sign of the larger, so the answer is going to be negative 8. I want to roll back just a little bit and talk about language and how some of these things are written and what it means. For example, subtract 7 from negative 3. That is not the same thing, if you remember, as subtract 7 and negative 3. Subtract 7 and negative 3 is going to be 7 minus a negative 3. That is different when we say from. So if you think about it, I have a total, in this case, well, from means you're taking it from the second number. Our second number here is the negative 3. So we're going to say negative 3 minus 7. Again, let's change it to an addition problem. Negative 3 plus a negative 7. They share the same sign, so we're going to add them together. The 3 and the 7 gives us 10, and keep the negative sign, so our solution is negative 10. Subtract negative 5 from 2. Now we're taking the negative 5 away from our second number of 2. So we're going to write it as 2 minus a negative 5. We're going to change it into an addition problem by adding the opposite of negative 5. So that's adding 5. So 2 plus 5 is 7. Now if we want to find the difference of 3 and negative 5, it's not the 3 that's getting taken away from the negative 5, it's just 3 minus negative 5. It's not a from in this case, it's an and. So 3 minus a negative 5, again, change it into an addition problem, add the opposite. If you add the opposite of negative 5, it's positive 5, so 3 plus 5 is 8. Let's change gears a little bit and start talking about geometry. If you remember, a circle, if we're standing in the middle of a circle and we walk to the edge, and we walk straight to the edge, that distance is called our radius. Now, if I started from one edge of the circle and I walked straight across to the very opposite side, that's our diameter. But halfway, starting from the center and going to the edge, is our radius. From a point, if I go all the way around a circle, that is 360 degrees. So it doesn't matter if I walk around the outside of the circle or if I walk in the inside of the circle. As long as I go all the way around a circle, that is 360 degrees. Why do we need to know this? when we start talking about angles, it's all based on a circle. So we have generic angles as complementary angles and supplementary angles. So complementary angles are two angles that add to 90. So in the first figure, I have a right angle, which is 90 degrees, and I've divided it into two angles. So angle X plus angle Y will add to 90. If I have a straight line and I've divided up that straight line into two different angles, those two angles are supplementary angles and they add to 180. Why? Because if I went all the way around, if I literally took all the way around, sorry, it's not very straight, that's 360. Well, I only went halfway, so that's 180. So whenever you want to think about it, you could draw more shapes. You could draw a circle, say that's 380, and I've just divided it in half, so I do know my two angles add up to 180. I've divided into a fourth, so that's 90 degrees. How would I use this? Well, if I am given one angle, and I can see that this is a 90-degree angle, I know those two angles, the one that's given and the unknown, will add to 90. So x plus 30 will equal 90. Therefore, my angle that I'm not sure about is going to be 60. Why? Because 60 degrees plus 30 degrees equals 90 degrees. Likewise, if I'm in the situation of supplementary angles, then I know both of my angles add up to 180. I'm given one of my angles, but I have to find the other one. So it's my unknown plus 45 degrees will equal 180 degrees. In other words, what amount does it take from 45 to get up to 180? 135. So x equals 180 minus 45 degrees equals 135 degrees. I do want to stress that every time that you do work with angles, you should have the degree marker. If you don't have the degree marker, you are missing the units. Just like if I told you 60, well, what do I mean by 60? Does that mean 60 minutes? Does that mean 60 seconds? Does that mean 60 degrees? Does that mean 60 gallons? Unless I give you the actual units, you're not too sure what I'm talking about. So it's always best to, well, you should always have your units attached to your value, if there is units to be attached. Anyway, that is this lecture. So until next time, be seeing you.